Hello, good morning everyone. My name is Shivacharan. I'm from the CSC department and today I'm going to give a presentation on superconductivity. And coming to the topic, Introduction to superconductivity. Superconductivity is a phenomenon where certain materials exhibit zero electrical resistance below critical temperature. This unique state allows for the perfect conduction of electricity without any energy loss. Superconductivity was first discovered in mercury by High-Kamerlingh Owens in 1911. This is a phenomenon where materials at certain conditions, when you impose certain conditions on them and reduce when their temperature is below a certain critical temperature, they exhibit a perfect conduction of electricity. This was discovered in 1911 uh, on mercury metal. And coming to key characteristics of superconductors, superconductors display two main properties: zero electrical resistance and the expulsion of magnetic fields, which is also called as Meissner effect. The critical temperature Tc is the temperature below at which material becomes superconducting. Different materials exhibit superconductivity at varying critical temperatures from near absolute zero to higher values. These are key characteristics as Meissner effect is a very important calculating the resistance and expulsion of magnetic fields. This effect is used to determine the type of superconductors and what is the electric resistance at, and the critical temperature is the most important and how to determine superconductor and at which a normal conductor becomes superconductor. Uh, Coming to the types of superconductors, superconductors are classified into two categories: type 1 superconductors and type 2 superconductors. Type 1 superconductors exhibit complete diamagnetism and have a single critical magnetic field. Type 2 superconductors allow magnetic fields to partially penetrate and are generally used in practical applications. And yeah, as we said about earlier, coming to the Meissner effect, the Meissner effect describes superconductor's ability to expel magnetic fields from its interior. This effect is a defining characteristic that distinguishes superconductors from normal conductors. It leads to the phenomenon of magnetic levitation, crucial for applications like maglev trains. This Meissner effect is crucial in determining the superconductor's ability to expel magnetic fields. This is used to calculate uh, this defines superconductors and this differentiates superconductors from normal conductors. This also leads to the phenomenon of magnetic levitation, uh, which is using current maglev trains, or which may you know as hyperloop trains, which is being currently developed in USA, which is a train with train which is made in a tunnel with zero electrical magnetic resistance, which has less friction, which can go at a very high speeds. And yeah, coming to the BCS theory or Barden-Cooper-Scheffer theory explains how superconductivity arises at low temperatures. According to BCS theory, electrons form pairs known as Cooper pairs, facilitating between a collective movement without resistance. This theory was pivotal in understanding conventional superconductors and earned its creators the Nobel Prize in Physics. This BCS theory was named after its three creators, Barden, Cooper, Schrieffer. And according to it, uh, when electrons form pairs known as Cooper pairs, they make a collective movement without resistance. And this theory was very momental, and it was very useful in understanding the superconductors and their how they work, and is also earned its creators a Nobel Prize of Physics. Coming to high temperature superconductors are materials that exhibit superconductivity above the boiling point of liquid nitrogen. These materials, primarily copper oxide ceramics, have become a significant focus of research since their discovery in the 1980s. Understanding the mechanisms between high temperature superconductors or HTS remains a major challenge in condensed matter physics. Uh, Generally, the superconductivity occurs at temperatures below critical temperature, which is usually not above boiling points. It's usually at low temperatures, but yeah, these high temperature superconductors are different from them, and these are mostly above the boiling point of liquid nitrogen. Liquid nitrogen is one of the most coolest substances which instantly freeze anything if you put into them. These these exhibit superconductivity at a boiling point even higher than their boiling point. So you can understand. So this made researchers curious, and they are significantly focusing and researching on them. And these have become a primary frames of focus of research. Uh, these superconductors mostly consist of copper oxide ceramics, uh, and yeah, understand the mechanisms has been a major challenge in this in the superconductivity topic. And coming to applications of superconductivity has transformative applications in various fields, including medical imaging and transportation. Magnetic resonance imaging (MRI) machines usually use superconducting magnets for detailed imaging. Superconducting materials are also essential in development of particle accelerators and quantum computers. And as you know about MRI, which is uh, currently one of the medical procedures used in hospitals, and like even if there is any sort of malfunction in your body, they ask you to get an MRI scan of your entire body, which is a very strong sort of body scan which determines everything and scans everything inside your body, through which you can determine what is wrong with your body and etc. This MRI scanners and machines use superconducting magnets for detailed imaging and use the magnetic forces to check inside your body thoroughly. And yeah, as I see, I said earlier, you can these are also used in transportations, as I talked about that hyperloop thing earlier, which is how this thing works is there is a cart or a train module which is magnetic. Its base is covered with magnets, and it goes in a tunnel which is also surrounded in magnets. In the inside of tunnel is magnetic. So when the base of the train and the base of the tunnel repels, so the train floats. And due to this and the repulsion forces and the attraction forces, train is able to achieve very high speeds. uh, and because there is not any friction, the train floats, and there's no friction, the train goes very fast and it is used to travel a large amount of distance at a short amount of time in a straight line. This is currently being developed. Uh, th- this has come into light in recent days, and we may see it soon. And coming to challenges in superconductivity research, one of the main challenges in superconductivity research is the need for cooling systems to maintain low temperatures. Finding materials that can be superconducting at room temperatures is an ongoing area of research. Additionally, the fabrication and scalability of superconducting materials pose significant hurdles for practical applications. And yeah, due to it being a complicated process, and there are many factors in the superconductivity research, such as the critical temperatures which need to be maintained at all sorts of times, and there can't be any small amount of temperature deviation. If there is any sort of deviation, it may disturb the entire process of superconductivity. So very precise amount of systems and uh, so much of individual care is required to make sure the superconductor state is in process and everything is going smoothly. And coming to current research trends of superconductivity, researchers are investigating new materials including iron-based superconductors and twisted bilayer graphene. The quest for room temperature superconductors continues, and new breakthroughs have been reported under extreme pressures. Advanced computational techniques are being employed to predict new superconducting materials. As you know about graphene, you know how durable the material is, and how it almost is how many times stronger than uh, iron is, and also revolutionary material. It is also a very good superconductor, and also it has the ability to transfer large amounts of energy and at a very high speeds. And yeah, they are trying to develop this technology as fast as possible and as much as possible. And due to it being a very complicated thing, as I said earlier, there are many factors to in this how this process. So many sorts of techniques are required to do to make sure keeping in check of everything to do this process correctly. And yeah, future of superconductivity. Future of superconductivity holds the potential for revolutionary advancements in energy transmission and storage. Efficient superconducting power grids could drastically reduce energy loss in electrical systems. As technology progresses, superconductors may play a crucial role in developing sustainable energy revolutions. Due to it being a very modular technology and very revolutionary choice of technology, uh, it has the potential to be integrated into different sorts of mechanism and different sorts of application and different sorts of industries, which may reduce significance of energy loss, power loss, and also labor reduction, and also many sorts of things. And due to it being uh, producing large amounts of magnetic energy, it can also reduce energy loss. And yeah, it has many potentials for energy transmission, storage, transportation, and it has in many fields such as medical too. And yeah, this has potential to be used in any sort of industry as we want. uh, there are researchers going on this, and as I said earlier, this is a complex thing, so we may see it soon enough in the future. Educational resources. Numerous online resources and courses are available for those interested in learning more about superconductivity. Universities and research institutions often offer seminars and workshops focusing on superconductivity research. Scientific journals and publications are great sources of the latest developments in the field. Uh, this is true as we ourselves have entire model about superconductivity and how they work. And yeah, there are many sorts of resources and online sources where we can study about superconductivity, and many universities are also encouraging the students to study about them, and they are offering seminars to explain about them, and if there are any ideas, they're also encouraging them to do the research. The hyperloop thing we talked about earlier, that was done by MIT students of USA. They made a mini scale model of the hyperloop, and which got approved, and now it is being turned into a project of a much larger scale. So yeah, there are many different sort of potential developments in this field. And yeah, uh, if people are interested in learning, you can learn it from the internet. And the data I've gathered in this presentation too is gathered from the internet. And notable discoveries in superconductivity. The discovery of cuprate superconductors in 1980s marked a significant milestone in the field of superconductivity. Recent advancements include the discovery of superconductivity in twisted bilayer graphene at relatively higher temperatures. Each new discovery paves the way for deeper understanding and innovative application of superconducting materials. As I talked about earlier, graphene is also a very good superconductor. This when graphene was recently discovered, this too was discovered as a perk of graphene, and which if we are evolutionize graphene, we can also work on the superconductivity technology. Uh, and yeah, the different sorts of metals which are being used as superconductors. Research is being done on different types of materials and which are superconductors or not. One of the major discoveries was when cuprate metal can be used to become a superconductor, which is a significant milestone in the field of superconductivity. And coming to the conclusion, superconductivity remains a fascinating area of physics with ongoing research and numerous applications. Understanding its principles can lead to significant technological advancements in various fields. The pursuit of room temperature superconductivity is a goal that could reshape energy systems and technological innovations. And the references are mostly taken from internet and also from our syllabus itself. And there are some of the websites. Superconductivity from Science Facts, superconductivity deficient types and applications. And the second website, Britannica, superconductivity physics properties applications. This particular articles, and these are the websites. Science Fact is the best website, and this is a particular article. And yeah, DOE explains superconductivity Department of Energy. So this is Department of Energy link. And yeah, thank you for listening to the presentation.